Um, Good afternoon, ma'am. Ma'am.
Ma'am, Sudha ma'am.
Good afternoon, ma'am.
Good
Am I
afternoon.
audible, ma'am?
Yes ma'am, yes ma'am. Okay ma'am, okay ma'am.
You can share your screen, ma'am.
Okay ma'am.
Ma'am, let us wait for a few minutes to join, the participants, ma'am.
Good afternoon, ma'am.
Ma'am, good afternoon.
Okay, ma'am. Welcome, ma'am. Ma'am, you can share your screen, ma'am.
Yes ma'am, I will share ma'am.
Yeah, okay, ma'am.
Yes, ma'am. It is visible, ma'am. Yes, ma'am. Sundar ma'am, shall we start?
Ma'am?
Ma'am, shall we start, ma'am?
Yes, ma'am.
Sundara ma'am?
Table, ma'am. Yes, ma'am.
It start. Okay. Good afternoon, all. Now I would like to introduce our guest of this afternoon session, Dr. A. Kavita, Professor, Department of ECE, M. Kumarasamy College of Engineering, Karur. Dr. A. Kavita received her PhD, Optical Communication Networks from Anna University, Chennai in 2011, ME Computer and Communication Engineering from Periyar Maniammai College of Engineering and Technology, Tanjore in 2004, BE Electronics and Communication from PSNA College of Engineering and Technology and Didikar. She is having more than 21 years of experience and authored more than 60 research articles and filed 2 patents. Her area of interest is optical communication network, and she received Dr. APJ Abdul Kalam Scientific Excellence Award in 2016 from Marina Labs Research and Development, Chennai. With this small introduction, I hand over the session to Dr. A. Kavita. Welcome, ma'am.
Thank you, ma'am. Thank you for giving a short introduction about me.
Thank you, ma'am. Welcome.
First of all, I would like to thank management and principal of PSNA College of Engineering and Technology. And I would also thank Dr. Jayanti ma'am, HOD of Biomedical Department, and Dr. Sudha ma'am, who is the coordinator of this AICTE sponsored Sttp on biosensors, medical imaging, and signal processing techniques for disease diagnosis. And at this juncture, I welcome the participants because this type of knowledge sharing platform will help their research. So I will start my session. Myself, Dr. Kavita. I am professor from M. Kumarasamy College of Engineering, Karur. In this session, let us see about how the optical sensors play a role in biomedical application. Actually, before going to the optical fiber sensors in biomedical, I would like to elaborate what is optical sensors. This is the agenda of this presentation. So I would like to begin this presentation with the introduction about optical sensors, and then I will go on why optical sensors, and then working principle of optical sensors will be explained, and classification of optical sensors will be given. Finally, I will give the details of application and how the optical sensors play a role in biomedical. So let us start from the introduction. Hope you all know that the new revolution of optical fiber sensors is going on in this decade. In the year 1960, laser light was invented, and after the invention of lasers, the fiber optic communication system has become the ultimate choice for gigabits and beyond the gigabits, that is terabits of data transmission. Actually, these fiber optic cables are non-metallic. They transmit signals using pulses of light. As a result, hope we all know that they are immune to electromagnetic interference because only light is going to be transmitted inside the cable. So they are immune to electromagnetic interference and radio frequency interference. Actually, in what we thought up to this decade is this type of optic fiber communication is used to transmit data, voice, telemetry, and video over a long distance communication. Actually, we thought that this fiber optic cable is used to transmit only the data with a high speed and with the full utilization of bandwidth. And after this data transmission, The scientists had started their research of optical fiber in the field of their applications, optical applications. So one among the application is sensor. Actually, the researchers combine the predictive results of optoelectronic devices by using the photon transmission, that is optoelectronic devices, with this fiber optic telecommunication devices. Actually, they combine the predictive results of optoelectronic devices with the fiber optic telecommunication devices to create fiber optic sensors. Actually, here the many of the components associated with optoelectronic devices are often developed for fiber optic sensor applications. In general, optical fiber sensor measures lights and its characteristics and produces a representative electronic signals. In optical sensors also, it is using the light as a transmission. So it measures the characteristics of light and produces representative electronic signal. Based on that, it will act as a sensor. When the light is affected, by external forces, optical sensors can be used as transducers to measure things such as displacement, temperature, even voltage and current. And the potential in sensing applications, optical fiber sensor has developed its own field. By using that refractive index profile will be developed. The ability of the fiber optic sensors has increased in the place of traditional sensor nowadays. Actually, it is a spin-off from other optical technologies. Some of the excellent characteristics features of this technology include lightweightness. Actually, light is having no mass because light is composed of photons which have no mass. So, light is having no weight. So, the characteristics of this optical is having lightweightness, low attenuation, smaller diameter, long distance signal transmission, transmission security, and so on. Next, let us see about what is optical sensor. Actually, a sensor that measures physical quantity based on its modulation on the intensity, spectrum, phase, or polarization of light. Actually, these are the characteristics of light traveling through an optical fiber. Here, the fiber optic sensors, also called as optical fiber sensors. Fibers have so many uses in the field of remote sensing. Actually, here, this optical sensors play a role in biomedical because it is used in the remote sensing, because they do not require any electrical power at the remote location, and they are in tiny in size. Both these advantages, these optical sensors are used in the biomedical applications. Actually, these sensors are used to sense some quantities like temperature, pressure, vibrations, displacements, rotations, or concentration of chemical species. And advantages of optical fiber sensors are compact in size, multifunctional. Actually, it is amenable to multiplexing. It is used in both point and distributed configuration, and it is remote accessible, resistance to harsh environment, and it is immunity to electromagnetic interference. For these advantages, we are using optical fiber sensors nowadays. So this is optical sensor. In this optical sensors, it is using the characteristics of light, that is intensity, phase, polarization, like that. It is using these parameters. This light, this optical cable is acting as a sensor. And let us see about fiber optic sensing mechanisms. We know that in optical fiber communication, there will be a light source. It is acting as a transmitter, and there will be a photo detector. It will act as a receiver. So the light is transmitted through the optical cable. So here the light is transmitted. For transmitting that light, there will be a separate source, that is a light source. In this light source, we can use either LED or laser, And the photo detector, we can use avalanche photodiode, pin diode, like that. So this is a normal optical communication block. So in this, we are using only the optical cable to transmit the light. So here the optical cable is placed, but here we are going to make this system as a sensor. So here we are placing the sensor in the optical cable. By placing the sensor in the optical cable, we are making it as a sensor. Here, whenever the light is passed through this cable, here the light parameters, the variation of the light parameters are measured. So the variation of light parameters is measured in this sensor by using this light characteristics. So it is called as optical fiber sensors. We can place this optical fiber sensor in remote applications also, not only in near applications. It can be used in the remote applications also. And here the optical fiber, instead of this sensor, we can use gratings, can be used as a sensor. Actually, the fiber optic sensor system consists of a fiber optic cable. Here we are having that cable, fiber optic cable, and it is connected to a remote sensor. And here in the second diagram, it is connected to the remote sensor. Either we can connect it to remote sensor or an amplifier. We can connect anywhere. Actually, we know that this fiber optic cable consists of a core surrounded by the clad material. Core surrounded by the clad material. The core is made up of either glass or plastic. So core and then surrounded by the clad material, and we can place this sensor inside the cable, or we can place the sensor outside the cable, and we can place this optical sensor near to the source and detector, or it can be remotely placed anywhere we can place. But based on the light characteristics which was given into this cable, this will be measured. The characteristics of the light will be measured by this sensor. This is the concept. Actually, these sensors are generally based either on measuring the intensity change or phase change. Actually, here the light is traveling, the light is propagating inside the cable. When the intensity is changed, then it will be measured. Or if there is any vibration, and it will be measured. If there is any polarization change, it will be measured. So based on the application, we can place the sensors. These fiber optic sensors are supreme for insensitive conditions, including noise, high vibration, and extreme heat, wet and unstable environments. These sensors can easily fit in small areas, because we know that fiber optic cables are very thin. So it can be inside that fiber optic cable also we can place this sensor. So it can be fit in small areas and can be positioned correctly wherever flexible fibers are needed. And let us see about the light parameters. Actually, here the characteristics of lights are measured by using this sensor. Only the light is transmitted. The light parameters will be measured by this sensor. So it is called as optical sensor. The light parameters are power. Actually, in the light, we are measuring the luminance power. We know that luminance of light beam is measured. That is called as intensity. So either we can take it as a power or intensity. And the next parameter is wavelength. Wavelength, all we know that lambda is equal to C by F. So either we can directly take the wavelength, or spectral distribution of that light beam, spectral distribution or polarization. And then phase. In the phase measurements, we can take the entire optical path. So these are the light parameters. The light parameters are power or intensity, wavelength, polarization, and phase. So based on the changes in these characteristics, based on the changes in the light parameter characteristics, here the sensor will measure the parameters. And what is the need of optical sensors? Actually, already I told that it is compact and lightweight, because light is having no mass, because it consists of protons. It doesn't have any mass. So this is lightweight, and here the light is transmitted. Light is having the nature of straight wave transmission. So we are using that the compact and light, and electrical isolation, and it is suitable for remote sensing. And it is having the immunity to electromagnetic interference, because inside the cable only light is transmitted. So this is immune to electromagnetic interference, and it is capable of monitoring a wide range of chemical and physical parameters. Actually, it is going to measure the chemical and physical properties, parameters. So this will be used in the biomedical applications also. Actually, these are the optical sensor measurements. Some of them are temperature, pressure, flow, liquid level, displacement, vibration, rotation, magnetic fields, acceleration, chemical species, force, radiation, pH, humidity, strain, velocity, electric fields, and acoustic fields, and so on. Actually, these are the measurements, some of the measurements of the optical sensors. By using the measurements such as pressure, flow, pH, chemical species, and strain, by using these parameters, we are using this optical sensor in the biomedical, that is in the healthcare industry. Next one, working principle. So already I told that here there will be optical source. So this will be on same as that of the optical communication. So there will be optical source and optical detector, and in between we will have one optical cable. So here the light is transmitted, but here in order to place a sensor, we are using a measurement zone. We are using a measurement zone. So here this signal is transmitted. Whenever required, we can place this actually this measurement zone is transducer. Here the sensor is placing. The light parameters will be measured here, and if there is any change, and it will be intimated to the detector. This is the concept. Actually, I am showing that figure again. Actually, source. The source will be LED or laser diode. So it will produce the light with the required wavelength, and this is passing through this is propagating through the optical cable, and there will be some sensing elements, that is transducer. Here we are using the transducer. It measures the measurement. What is the measurement we are needed? For that purpose, we are placing the sensor, so it will measure that measurement. And there will be end processing, that is optical spectrum analyzer or oscilloscope. By using that, we can measure the values. And this detector is used for the purpose of detecting the values, receiving that value. And here it uses the concept of light beam changes by the phenomena that is being measured. Actually, the sensor concept is light beam changes by the phenomena that is being measured. Actually, here light is going when the light is affected by any external forces. When the light is affected by any external forces, the optical sensors can be used as transducers to measure the light parameters. That is the concept. That is, light beam changes by the phenomena that is being measured. When the light is affected by external forces, optical sensors can be used as a transducers to measure the light parameters. The light may change in its optical properties, like intensity may be changed when this is transmitting from here to here. The intensity may be changed, or phase changed, or polarization changes, or wavelength, or spectral distribution changes. So based on the parameters of the light, the transducers, that is a sensor, optical sensor, will measure the changes. Actually, this is one example. Actually, here there will be one network. Here the intruder is coming. We are having the optical sensor here. This is a sensitive, a light sensitive element. Optical sensor means this is a light sensitive element. Here one intruder, here the intruder in a network is identified based on the light intensity changes. Actually, there will be light passing. Here we are having the magnification purpose lens, and one sensor is placed. When one intruder is coming inside, this will be magnified and it will be given to the sensor. Actually, the intensity of the light is changing here. The intensity of the lighting changing here. So based on that, intruder will be identified. And here the direction of the movement, that actually we are light parameter is having phase, polarization, wavelength, intensity. Here the movement also measured. The intruder movement, direction of movement also measured by using this sensor. Here this is based only on the light. These are the sensing details. Actually, the intensity we can form intensity based sensor. If the intensity of the light is changing, then we can manufacture the intensity based sensors. Or if there is any frequency changing, then we can make wavelength varying sensors or frequency varying sensors, because omega is equal to lambda by c, sorry, lambda is equal to c by f. So based on that, frequency varying sensor or wavelength varying sensors will be manufactured. And phase modulating, that angle changes, so based on the angle changes, phase modulating sensors will be manufactured. And polarization modulation fiber sensors are there. So based on these characteristics, here the sensors will be used. The optical fiber sensors are classified into three categories. One is based on the location, and another one is based on the operating principles, and another one is based on the application. So based on the sensor location, it is of two types. One is intrinsic and another one is extrinsic. Actually, in the intrinsic sensor, the sensors are embedded inside the fiber. Actually, the sensors are embedded inside the fiber, or it will be the part of the fiber. Here we are having the source and the detector. In between, fiber optic cable will be placed. So in the case of intrinsic fiber sensors, the sensors are embedded inside the cable, or it will be the part of the cable. That is the intrinsic sensors. And this type of sensors, sensing takes place within the fiber itself. Actually, here it will be the part, or it will be embedded inside the cable. So the sensing takes place within the fiber in the case of intrinsic. In the case of extrinsic, the fiber carries the light from the source. Actually, here we are placing one cable between the light source and detector. So here the light is from source to detector. The modulation, actually here the extrinsic is, it is going to be placed outside the cable. In the intrinsic is, it is going to be inside, or it should be embedded. So here in the case of extrinsic, it should be placed outside. So here the modulation, so the modulation is based on the intensity. So the modulation occurs outside the fiber, that is called extrinsic fiber. This is the diagrammatical representation of intrinsic sensors. So here we are having the light source, and here we are having the detector. So in between that light source and detector, the sensor will be placed. Actually, this sensor will be embedded inside, or it will be the part of the cable. So here, whenever there is a change in the environmental signal, the modulation will occur inside the cable. That is the intrinsic sensors. Whenever there is a change in the environmental, then there will be a modulation occurs inside the fiber, that is intrinsic fibers. That changes will be measured, the changes will be sensed by this sensor. Actually, here the sensors depends on the properties of optical fiber itself to convert on environmental action. Whatever may be the environmental action, there may be some strain or stress. So it converts the environmental action into a modulation. Actually, here the environment, if there is any strain or stress, this environmental action is converted to modulation of the light beam passing through it. Here, one of the physical properties of the light signal may be in form of frequency changes or phase changes or polarization changes or intensity changes. So here, based on the environmental signal affected, there may be a changes of the light characteristics. Any of the light characteristics will be changed. That changes will be measured by this transducer. That is an optical sensor. Actually, this is used in distributed sensing. Actually, this type of sensors are used in the distributed sensing over long range distances. So this is intrinsic type sensor, and next one is extrinsic. This is the diagrammatical representation of extrinsic fiber sensors. Here, as usual, there will be a light source for transmitting the light, and there will be a light detector to detect that light. Here, there will be sensor that is placed outside the cable. Here it is called as block box. It is called as block box. Actually, in the case of extrinsic, it will be placed inside the cable, but here it will be placed outside the cable. It is called as a block box. Actually, it is external to this block box. That is, this transducer or this sensor is external to the cable. That's why it is called as extrinsic sensor. Here, if there is any changes in the environment, then it will be stored here. Actually, if there is any environmental changes, that environmental changes will affect the light, that will be stored in the block box. That is a concept. Actually, here the fiber optic sensors, this fiber optic cable is used to carry the lights, but the information changes, any changes in the environmental condition will be stored in the block box. So based on the block box, the intensity or the modulation will be done in the fiber optic cable, and it will be received by the light detector. Actually here it generates a light signal. This block box generates the light signal depending on the information arrived at the block box. Actually, this block box covers the environmental changes, and this block box may be made up of mirrors or gas or any other mechanisms that generates the optical signals. Actually, this will be the optical signal generation, and we can place a mirror or gas or any other mechanisms to generate the optical signal here. Actually, this extrinsic sensors are used to measure the rotation, vibration, velocity, displacement. Actually, if there is any vibration, then it can be measured. So like that, it can be measured the rotation, vibration, velocity, displacement, twisting, acceleration. So these types of parameters will be measured by using this extrinsic sensors. And example for this extrinsic sensors are, it is used to measure temperature of the aircraft jet engine, and it is also used to measure the internal temperature of the transformers. So for these places, these extrinsic sensors are placed, and it is measuring these values. And this is the comparison of extrinsic and intrinsic optical fiber. Both are based. Actually, it is both are location based, and application wise, this extrinsic is, it is used in temperature measurements, pressure, liquid level, and flow. And this intrinsic is used in the rotation for the measurements of rotation, acceleration, strain, acoustic pressure, and vibration. And this is used for the less actually this is less sensitive because it is placed outside the cable, so it is less sensitive. But here it is more sensitive because it is placed inside the cable. If there is any small changes, then it will measure the changes parameters, but so it is more sensitive. And here it is easily multiplexed because it is placed outside the cable, so the multiplexing is easily done. But it is placed inside that, so tougher to multiplex. And here ingress and egress connection problems, because already we are laying down the cables. So now we are going to use another one box or one transducer or one sensors to place. So already placed means then it will be a problems, but here it is inside the cable, so it reduces the connection problems. And this is easier to use, but this is more elaborate signal demodulation is required here. And it is less expensive because we are going to place the sensor alone, but it is more expensive because in addition to the cable, the sensor will be embedded, so it will be more expensive. And another one is based on the operating principle, and this intrinsic and extrinsic is based on the location, and next type is based on the operating principles. Intensity based, phase based, and polarization based. There are three types: intensity, phase, and polarization based optical fiber sensors. This is the diagrammatical representation of intensity based fiber optic sensor. Meaning is intensity variations will be measured. Intensity variation is measured. Actually, multi-mode fiber is used in the multi-mode fiber, and also the another advantages, it will be used in the remote applications. Remote applications it will be used. Intensity based fiber optic sensors requires more light, and these sensors uses a multi-mode optic fiber, multi-mode core fibers. When there is any vibrations, actually consider this diagram. If there is any vibrations occurs here, either this side or any from this to that, if there is any vibration, that vibration will be measured. And there is any vibration, there will be a change in light inserted from one end to next end, and the vibration amplitude is measured. The vibration amplitude is measured by the sensor. So the vibration changes. So based on this light, whenever the light is coming, if there is any vibration, that vibration amplitude is measured in the intensity based fiber optic sensor. But the problem is, if any signal is, if a light is coming through one micro bending or macro bending or at the splices or at the coupler, the signal is going inside the coupler and it will be coming. So there may be some slight vibration, but this vibration also measured by this type of sensor. So these sensors have many limitations due to this variable losses in the system. That losses include splices, due to splices, micro bending, macro bending, and losses due to connections. There will be some connectors. So connectors and at the joints, if there is any box, any components will be inserted, then automatically there will be some vibration. That vibrations also measured by this sensor. So this is intensity based sensor. That is the intensity of the light is varying. That intensity variation is taking as a vibrations. And advantages of this intensity based optical fiber sensors are simple signal processing, because only it is going to measure that vibrations. So this is a simple signal processing, and this is inexpensive measurements instrument. And disadvantages are, this is vulnerable to power fluctuation of the light source, because if there is any fluctuation, then this will be considered as a vibration and it will measure. And this is susceptible to fiber bending loss. If there is any bending, automatically there may be minimum vibration, that vibration also measured. And here it is using the multi-mode fiber, so automatically there will be a model power distribution. The variation in model power distribution will also causes some error. And the next type is polarization based fiber optic sensor. Actually, this is based on the principle. The second type is polarization based fiber optic sensors. Again, we are having the same setup, that is light source and detector. Within that, in between that light source and detector, we are going to place one polarizer and analyzer. It is a special type of fiber. The components have been developed with exact polarization features. Actually, the components here, have been developed with exact polarization features, because based on the polarization changes, the sensors will use. So here, these components are developed with the exact polarization features. It is shaped by polarizing. Here it is using the concept of light from the light source through a polarizer. Light from the light source through this polarizer. The polarized light is started at 45 degree. Actually, normally it is in straight way. So here we are going to place a polarizer by 45 degree to the selected axis of the length of the fiber. The phase difference between the two polarization states, because here the light is coming and it touches this polarizer, this is starting from the 45 degree, and if there is any stress, any external stress, then this signal polarization will be changed, and this will be measured by this analyzer. like stress or strain. The phase difference between the two polarization states. Already this is 45-degree polarized, and now because of this external stress, the polarization will be changed. So these two polarized. This is one reference, and another one signal is passing. So the two polarization states is changed under any external disturbances like stress or strain. So according to the external disturbances, the output polarization will be changed. Actually, there will be two things will be propagated. One is reference signal. I will show in the next slides. Actually, here the light is coming from this light source. There will be one polarizer at 45-degree, and the reference signal will be passed, and another one signal is passing here. Another one light signal, that is stressed signal, that is external stress or strain signal will be passed. So the polarization of this stressed signal will be changing. By using these two signal, analyzer will compare these two signals, so the polarized changes will be notified here. Actually, generally these types of fibers, polarization fibers, are used in the signal processing applications. And next type is phase-based fiber optic sensors. This is based on the operating principles. This is the third type. There is a phase-based fiber optic sensors. These types of sensors are used to change emitter light on information signal, wherein the signal is absorbed by the phase-based fiber optic sensor. Actually, here we are in this slide, we are taking the Michelson interferometer and Mach Zehnder interferometer. Here, from the source, the signal is coming. By using this 3D coupler, this signal is separated into two parts. One is reference signal, and another one will be, actually already I have told here. Actually, there will be one reference signal and another one signal is going, and this signal will be affected by the external stress, and this will be measured by the analyzer. So like that, here also the signal will be splitted into two beams. The source signal will be splitted into two beams. In the base-based fiber optic sensor, it will be separated into two parts. So one is for the reference signal and another one is for the sensor. So here there may be some variations in the light parameters that will be measured by this transducer, and these two signals will be compared for the good quality mirror. There is a phase-based fiber optic sensor. Here, normally two interferometers will be folded with each other. In this case of phase-based fiber optic sensors, two interferometers are folded with each other, because here it will be going one reference signal and another one reference signal, and it will be combined at the end. So here in this slide, it shows Michelson and Mach Zehnder interferometer. Here the incoming signal will be splitted into two beams. One is for reference and another one is for sensor. Here if there is any change in the phase, again it will be measured by this transducer and it will be compared in the N phase. So here the mirror N phase will be there. So here for the folding purpose, another one Mach Zehnder interferometer will be placed here. And this is for the operating principle. So based on the operating principle, there are three types: intensity and phase based and polarization based. And next one is based on the application. The optical fiber sensors are classified into three types: chemical sensor, physical sensor, and biomedical sensors. Chemical sensor, physical sensor, and biomedical sensors. Chemical sensor is a device which is used to transform chemical information. Actually, chemical sensor is a device which is used to transform chemical information in the form of measurable physical signal that is associated with the concentration of chemical species. Actually, it is for the purpose of measuring the chemical properties, chemical information in the form of measurable physical signal that is associated with the concentration of chemical species. This sensor is having the two functional units. One is a receptor and a transducer. Actually, in the chemical sensor, it is having two parts: receptor and transducer. In the receptor part, the chemical information is transformed into energy. Actually, the chemical part is transformed into energy that is going to be measured by this transducer. That is going to be measured by this transducer. The transducer part, the chemical information is transformed into analytical signal. Actually, the chemical information is transformed into analytical signal. I will show some examples for this chemical sensors. The next slides. Actually, this chemical information is transformed into analytical signal. The chemical sensor is an important component for the analyzer. The chemical sensor is an important component for the analyzer for analyzing the input signals. Here also, it is also used in the signal processing, sampling, and data processing. The next one is physical sensor. Actually, it is a device that is made according to the physical effect and nature. Physical sensor is for the purpose of in the biomedical, it is used for the physical pathological properties. So it is a device that is made according to the physical effect and nature. These sensors are used to provide information about the physical property of the system. That's why it is called as physical sensors. So physical property of the system. It is used to measure physical properties like temperature, stress. Actually, this type of sensor is mostly signified by sensors such as photoelectric sensors, piezoelectric sensors, metal resistance, strain sensors, and semiconductor piezoresistive sensors. And the next one is biomedical sensor. Actually, biomedical sensor is an electronic device. It is used to transfer various non-electrical quantities in biomedical fields into easily detectable electrical quantities. Actually, here it is used to transfer various non-electrical quantities like heart rate and pressure. So it is used to transfer various non-electrical quantities in biomedical fields into easily detectable electrical quantities. Due to this reason, these sensors are included in the healthcare analysis. This sensing technology is the key to collect human pathological and psychological information. That's why it is used. This biomedical sensor is used to transfer various non-electrical quantities into easily detectable electrical quantities. It is used to measure physical properties such as temperature, displacement, velocity, strain in structures of any size or any shape. And in real time, it is used to monitor the physical structure of health. So let us see some examples of this optical fiber sensors in biomedical. In this slide, I have shown one example for breath analysis using tunable diode laser. Actually, here the breath samples are collected, and laser light is passed through that breath samples. Actually, here sometimes many chemicals are converted into species and reactive products are generated inside the human body. So chemicals, if suppose inside some chemicals are there, then it will be in the way of food or water. So these chemicals are converted into species and the reactive products are generated, and the breath samples will notify that. So this breath samples will be collected and it is passed to the light is passed, and based on the changes in the parameters, the chemicals will be identified. So this is the an example for breath analysis using tunable diode laser. And this is another one example, the fiber optic sensor in optical heart monitor. So this is marketly available products, and this is the phenomena. Actually, here optical heart rate monitor measures the heart rate using the light. Here a LED shines through the skin and our optical sensor examines the light reflected back. Actually, here LED will be fixed. So based on the LED light, and this light will be detected. So based on the heart rate, the vibrations will be varying, intensity will be varying. So that light will be reflected back and it is collected by the light detector and it will be measured. Here, since blood absorbs more light, fluctuation in the light level can be translated. Actually, whenever we are fixing this heart, optical heart monitors, then here the light is passing through the blood. The blood absorbs the light and the fluctuations in the light level can be translated into heart rate. This is the process called photoplethysmography. Photoplethysmography. This is the principle of photoplethysmography. Here, the light, LED light will be shined. So this will be absorbed by the blood samples and bloods, and based on the blood movement, here light, the light will be reflected back. So based on that, it will be measured. So blood, based on the fluctuation in the light, the optical heart rate will be measured by using the optical heart monitors. And some other examples are, actually this OFS, that is optical fiber sensors, are used to detect the dengue fever. To detect the dengue, already we are having a lot of technology. Even though we are having a lot of technology, nowadays we are using the OFS. Many lab testers available to detect the dengue fever, but all are taking long time and it needs a highly knowledgeable personnel. But nowadays a fast and good simple method to diagnose this disease is optical fiber sensors. The phenomena here used is LSPR, that is localized surface plasma resonance. Localized surface plasma resonance phenomenon is used in the optical fiber sensors to detect dengue. Actually, here it uses the concept of refractive index changes. Actually, the light is the cable is consist of core followed by the cladding. There will be two different refractive index in the core as well as clad. So here it based on the properties of change in the refractive index. Actually, when the light is influenced on the material enclosed by dielectric material, spectral changes will occur. If there is presence of dengue, then the spectral changes will occur. So it will change the refractive index. So based on the refractive index changes, it will be identified. And it is used to diagnose DNA also. And to measure sugar, blood, cholesterol in blood sample. By using that, already I have shown one diagram, that is for one reference signal, and another one is normal signal that is going through the optical cable. By using that concept, this is measured. Actually, in the blood samples, the contents like sugar, protein, cholesterol, extra are being measured, but it takes time. If the laboratory is placed remotely or the patients will be placed remotely, by using this optical fiber sensors, it can be easily measured. Actually, it is fitted into catheter. This optical fiber sensor is fitted into catheter and it is placed in the blood vessels, and continuous measurements are handled by this optical fiber sensors. If patient is not near to the optical lab, then it can be measured by using this optical fiber sensors. And physical sensors are used to measure the physiological specification like body temperature, blood pressure, and muscle displacement. Actually, this is measured by using the physical sensors. And another one application is to measure carbon dioxide pressure in the stomach. Usually, the OFS, the optical fiber sensors, are used to measure the carbon dioxide pressure in the stomach. This sensor is based on the color change of carbon dioxide sensitive indication layer. Again, it uses the concept of that refractive index. Actually, this layer is connecting to the optical fiber placed in the stomach. The optoelectronics unit is attached to the laptop or computer for the data acquisition and processing and for calibration. So by using refractive index changes, again the carbon dioxide pressure will be measured in the stomach. And glucose sensor. Actually, in this glucose sensor, it uses the concept of Mach center interferometry. That is optical sensor coupled with Mach center interferometric waveguide. An optical fiber is used to measure slight changes of aqueous sugar concentration. Actually, if we are considering the sugar concentration, one will be aqueous and another one will be given. That is, in the Mach Center, we know that there will be two signals. One is for reference and another one is for changes. For another one is for propagating. So here the sugar solution is taken for reference, and another signal is for the purpose of measuring the changes. This type of sensor is high sensitive, simple, reliable, and is used for continuous monitoring of glucose. In this method also, refractive index change. Actually, here also it is using the concept of refractive index changes with the concentration of sugar. In this method, one arm of interferometer is covered with glue and isolated from sugar solution, and other one is defined sugar solution. That is, one end is for a reference signal and another one end is taken signal. That is, that light is propagated through that sugar solution. So that is the blood sample taken from the patient. So based on the variation, it will be compared with the reference signal. So this will be happened in the analyzer. Then it will be checking the glucose level of the blood. If the concentration of the sugar is changed, the phase of the propagating light is changed. If the concentration of the sugar is changed, that is a phase of the propagating light is changed. So that is, phase-based optical sensor is used here to measure the glucose. That is called as glucose sensor. The glucose sensor, it uses the concept of phase-based optical sensor. Phase of the one arm is not changed, it's remain constant, that is a reference. So the output intensity from the interferometer is directly related to the concentration of the sugar solution. So here it uses the concept of refractive index changes, and here it uses the concept of phase-based optical sensors. And optical sensors are also used in MRI fiber optic sensor for brain injury. So here it is used to sense the angular position. Here it is used to sense the angular position and capture the velocity and acceleration during the operation. And the data is corresponding to the real image with the MRI image, the real-time MRI image. And MRI fiber optic sensor for cardiac stress testing. Actually, this is used for remote sensing also. So even a treadmill and image system is located remotely, we can get a cardiac stress testing result. And this MRI fiber optic sensor is used to provide the patient safety over ultrasound techniques. Nowadays we are having that MRI scanning. In this there will be some noises will be there, but here by using this fiber optic sensors, the type of noises will be reduced. And next one is respiration and heart rate and flow, blood flow measurements also used. That is used to measure the periodic mechanical movement of the chest wall. By using this OFS, periodic mechanical movement of the chest wall will caused by breathing measurements, breathing or cardiac contractions, and hence monitor the respiration and heart rate by placing optical fiber sensors. And some other examples are measuring the blood flow, testing skin irritants, blood perfusion measurements in the stomach, long-term health assessment, obtaining fingerprint image. In healthcare, biosensors can be used to detect the biomarkers or to detect bacteria directly, and so on. So optical fiber sensors are used in biomedical. And beyond the, as of now, what we taught is optical is only for the data transmission. So beyond the telecommunication, it is used in medicine field, biological and genetics research, defense, industrial material processing, chemical and pollution sensing, next generation lasers, optical data processing, transmitting light beyond the near IR, and so on. So here I am showing some images for optical fiber sensors. Actually here the foreign body removal, in the foreign body removal optical fiber sensors are used. Actually here the foreign body is removed by inserting the optical cable, and light is propagated inside that by using some light source. The light is traveled here. If the intensity of the light is changes, that is the parameter of the light is changes, based on that this foreign body will be identified and it will be removed. And this is the one image for identification of lung cancer by using the laser light and camera. The lung variations will be identified. Actually, this is the method to replace the physical biopsy. And optical fibers sensors are also used in the measurement of pH level. And as we all know that the ENT headlamp will be there, that is the light. So by passing that light, it will be cleaned or the disease will be identified. So I want to show one video to you.
Board demonstrates ambient light, proximity, and gesture sensors with an I2C digital interface. On this evaluation board is the SI1153, which can detect proximity and ambient light, and the SI1133, which can detect UV and ambient light. These sensors can work indoor and outdoors and can be used in a variety of applications to fit your designs. There are 5 switches on the sensor board, each used to activate a specific sensor. The first switch selects the UV or ambient light sensor, which provides a UV index score which can be used in a variety of applications, such as smart wearables which monitor UV exposure, or smart agriculture to compare sun activity with crop status. The SI1153's ambient light sensing is demonstrated by an on-screen light bulb that varies in brightness. Ambient light sensing is useful for night lights and backlight control. The board also includes the SI1153, which is a low-power proximity sensor that detects the presence of nearby objects. As part of the demonstration, after turning on the 4th switch and moving your hand up, black and white squares collect and grow larger or smaller on the display screen. Proximity sensors are included in many devices, such as motion-activated sink faucets and soap dispensers, which turn on when they detect the proximity of a human hand. The SI1153 also has long-range and direct sunlight application capabilities, which are demonstrated by turning on the 2nd and 3rd switches. With the long-range switch activated, the sensor with a lens attachment can react to objects between 3 inches and 6 feet with very low power consumption. The sunlight immune proximity sensor, activated by the 3rd switch, can detect proximity even in open sunlight. This is useful for outdoor applications such as electronic entry locks, which can sense your keycard even if... The SI1153 also has the capability to detect gestures, activated by the 5th switch. This can detect gesture movements of left, right, up, and down between 1 and 4 inches from the sensor. Gesture sensors can be used in the smart home market to control thermostats or smart hubs, allowing for a touchless interface. As you can see, there are various applications that utilize these sensing capabilities. With its ambient light, proximity, and UV capabilities, our SI1153 and SI1133 open up a new world of possibilities in your designs. To learn more, visit scilabs.com.
Welcome to the TI Precision Lab series on light sensors. My name is Alex Bandar Young, and I am an
Different types of optical fiber sensors now. And before that, the clinicians must understand the OFS technology to know the overview of hurdles during the deployment of developed technology in healthcare. That is important. And looking at the healthcare industry in this decade, it seems that there is going to be a lot of research and improvements to the existing sensors. Actually, fibers are everywhere. So fiber optic sensors offer great potential for healthcare applications. Optical fiber sensors are stay in future. Actually, I have read 2 articles. That is, fiber optic sensors are used in identifying the COVID-19, screening of COVID-19. These fiber optic sensors are used. Actually, it is published now itself, that is June 2020. So optical fiber sensors are playing a role in identifying the COVID-19. And another one article, that is fiber optic nanophotonic approach for the detection of antibodies and viral particles of COVID-19. So hope optical sensors are stay in future. Actually, this is one image for fiber optic sensors used in biomedical. Actually, this is for sensing the oxygen, brain tumor, cosmetic treatment, dental treatment, spine surgery, and varicose vein treatment, cancer therapy. So this in biomedical field, optical sensors play a role. Actually, with optical fiber sensors today continues to innovate in the biomedical field. Actually, in future, it will be actually nowadays it is optical fiber demand in novel technologies like Raman and attenuated total reflection concept. Actually, as of now, what we have seen is by using the total internal reflection, refractive index, the measurements was taken. So here in future, the reflection total reflectance concepts will be used. Then it will be used for the communications, military and defense and biomedical images. Actually, bringing a medical device to a market is costly process due to the need of comply with medical device regulation and clinical studies. It is therefore important to understand early in the development process whether the device is required. But whenever one healthcare product will be developed, it is following the approach. So in today's technology, the top-down approach of guidance is given by National Institute for Health and Care Excellence. That is nice. National Institute for Health and Care Excellence in UK aims to take an evidence-based approach to recommend medical devices and influences adoption decisions. So they suggested that optical fiber sensors for future life. So hope laser focuses the world. So optical fiber sensors will be the future trend. And these are the references I have made. Thank you. Thank you, ma'am.
Thank you, ma'am.
Thank you.
On, sir.
Participants, do anybody have any queries? You may ask now. Dear participants, if you have any queries, you may ask now. Unmute yourself and speak.
Ma'am,
Yes, ma'am. Yes, ma'am.
MRI fiber optic cable. So,
Yes, ma'am.
MRI fiber optic sensor. Is there any difference between general sensor and MRI sensor, ma'am? Since it is used with MRI.
Yes, ma'am. Actually, I have shown that, no? Actually, in normal, if suppose we are taking MRI, there will be some noises will be there.
Yes,
But
ma'am.
by using this fiber optic sensors, the exact measurements will be taken, ma'am. And without that, if a patient is laying on the bed, then the sound will create a problem to them. But without this sounds, that the MRI scan will be taken. And another one is this MRI testing will be taken from the remote location itself. But now we should be go to the labs and we will take the test. But by using this fiber optic cable, that details will be transmitted through the cable and it will be measured. Even the patient will be in the remote location, or the lab will be in the remote location. It will be measured. The noises will be reduced, ma'am.
Okay. Okay, ma'am. Thank you, ma'am.
Okay, thank you.
Thank you, ma'am.
Thank you, sir.
It is indeed a great pleasure for me to deliver the vote of thanks. On behalf of the Department of Biomedical Engineering, PSNA College of Engineering Technology, I would like to thank Dr. A. Kavita, Professor, Department of ECE, M. Kumarasamy College of Engineering, who gave a very nice talk on fiber optic sensor in biomedical application. I'm sure that the participants would be highly benefited from a talk. Thank you, ma'am.
Thank you, sir.
Thank you very much, ma'am. Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.
Participants, we'll meet you on the next day, tomorrow, by 9:30 a.m. See, feel free to ask question. It may be a silly question or maybe a wrong question. Don't worry about that. Interact with the speakers. Okay, please be interact with the speakers. Okay? Either you can use chat to clear your doubts. Okay. Thank you very much. Thank you, participants. We will meet you tomorrow in the first session at 9:30 a.m. Thank you.
Everyone can leave the session. Thank you.